And welcome back. Now today we're going to have a quick chat about a couple of things, one of which has been a little bit of an irritant for some time, and it's these things on my desk, breadboards. Now there are cheap breadboards and there are, well, slightly less cheap, I suppose you call them really, wouldn't you? But some of them are just downright awful, and they've been annoying me for quite some time. Now, as I said, I used to play around with PIC. So this, for example, is a PIC development board. This little board here is okay. Okay, I don't use that anymore though. Not now I'm doing Arduino stuff. Then I've got this huge big thing underneath all here, which once again I bought mainly because PICs are just a bit more, what's the word, expansive, I suppose. You need to build more things around them. No idea what that is. It's probably about 3 years old sitting on there. Anyway, that was quite a good one, but actually it's too big for use with Arduinos. There's just too much of it. So that one's been put to rest. However, as you've probably seen countless times in my videos, I use little tiny breadboards like this when I need them. They do clip together. That's a double one, incidentally. It's not clipped together, but these clip together and then immediately fall apart again. And they do have a sticky pad on the back. But I've never actually stuck it to anything. It just gets, well, if anything, anchored to this green mat with a bit of blue tack when I need it. But the problem is with these boards is that sometimes the holes are just, I don't know, they're not designed correctly for thin components. And the reason I'm even doing this video, because I threw away a couple of breadboards, I don't know, probably about a month ago. And then it dawned on me as I got out some new ones, like, should have done a video on that and explained it. So I'm going to explain it now anyway. So what's the problem? Well, these boards are okay. So if we get a little component like this and try and put it into one of these holes, it should just, just go in pretty much. I'm trying to do this on screen. So as you push it in, it goes in. Now, some boards, like the two I threw away, as you push them in, you see, you just saw that lead bend there a little bit, like that. So you see that bending? It just wouldn't go in now. Okay, I've deliberately orchestrated that to bend at the moment because I'm holding it in a cack-handed fashion. But that's what would happen if you had a duff board. So I saw some other boards on the, I think it was AliExpress or Banggood or something like that, and it said transparent, and I thought, perfect, I'll be able to see what I'm putting stuff into. Well, it didn't quite work out like that, although yes, you can see the metal receivers here, if you like, the little graspy bits. You can't really see inside. It's not like glass, is it? This, incidentally, is two put together. There's another couple at the back that you might have seen when I was doing my RS485 video a little while ago. I haven't destroyed that yet. So how do these bear up? Well, frankly, I don't think they're any worse or particularly any better than these are the white ones that I used, but they're okay. Now the trick, if I can get it close enough to the lens here without blocking all the light, is that the hole, as you can see all these holes here, somewhere I've got a pointer, let's use that, so much better, isn't it, my fat stubby finger. These holes have got to be open for the component, so the metal bit really shouldn't be showing hardly at all. Well, ideally not at all, frankly, because otherwise you're going to put a component into this hole, hit that metal grasper header socket, and then it will bend the component. So the less you see of that, the better. So these ones, let's have a look. If I just line that up and push them in, are they going to go in? Pretty much. Is that in? Let's have a feel. Oh yeah, it is in. Okay, so they're not bad. And I'm deliberately using these resistors because they got fairly thin leads. If you were to use, I don't know what was on the other one. So on here, for example, if you got diodes, LEDs, they got thicker leads anyway, so you probably wouldn't notice a difference. Oh yeah, while we're on the subject, I'll just continue my ongoing rant that if you're going to buy new resistors, and you can get whole packs of E24 resistors from Banggood and AliExpress and all that, all the ranges you'd ever need, far more than you need actually, but the complete range for, I don't know, just a few dollars, a few pounds. And I recently replaced all my resistors. Well, I say replaced, I augmented them, but then I am thinking long and hard about using some of the old ones because I've had them so long, the leads have started to sort of corrode a bit. So I replaced all of my resistors, and it came in a pack of about 500 or something like this. And you might say, what's wrong with this? Well, my answer to that would be, what's right with this? Now, like many people, I learnt the 4-bar or 4-ring resistor code as a young teenager, really, so I can read the values of a resistor by sight. And you go, well, why is it so difficult for a 5-band? It's only sort of divide by 10, isn't it? To a degree, yes. But can you make out on this video what those colours are? I mean, it's really difficult, isn't it? I mean, look at it. Sort of a muddy brown and a, well, whatever it is. I'll zoom in a little bit on this if you like, and you can have a look a bit more. But it's really difficult to read those colours because it's on this blue background. And that is really, really frustrating. So basically, I gave these away to somebody, an Arduino follower, who just used a meter basically to read them. And then I reordered from Banggood again. I mean, you think I'd have learnt my lesson. But this time, I made sure the picture showed, let's get rid of some of this. The picture showed them like this, which was beige for one, so it didn't alter the colours, and 4-band. So now I'm happy because I can read the colours for one, and even happier because it's a 4-band resistor, and I can read them more or less by sight, unless there's some obtuse value. You know, if you start going up into the mega ohms, I think, just a minute, I'll have to get my meter out for that. Well, that's all there is to it, really, and it costs, I don't know, I think it's about £4, something like that. If I find my original order, because this is going back some time now, I'll put a quick snip into the video as I'm talking about them now. So just beware that if you're going to buy any component, really, whether it's resistors or capacitors or anything, make sure you can read the values, or at least know what you're looking for, or got a meter handy so that you can always double check the values. Anyway, that was a bit of an aside, really. So if you're going to get a breadboard, or have got one and you're finding it a problem because you can't put the components in properly, have a look around. Now these ones are, as it says, transparent, so you can sort of see through them, can't you? Sort of. It doesn't really help, frankly, when you're putting components in the middle, but they're okay. I'll say that. Well, I wouldn't say they're brilliant, but they're okay. And at least I can get components in. I've got a little diode here. Let's have a look. In fact, I'm going to take myself off. There we are. Now I can bend over and look at it properly. So if I was sticking that in there, for example, a little bit of resistance. It's probably the Kakadu. I'm not left-handed for one, so it doesn't help. Oh, that did go all the way in, actually. I thought it wasn't in, but it most certainly was all the way in. Yeah, a little bit of resistance on that one. It was okay. That was in all the way. So that's my first gripe. Get yourself some decent breadboards, because I think we have enough frustrations getting these things to work without the breadboard letting us down. And, in fact, the two I threw away, they were a few years old, a bit like this, although the letters on the bottom were in capitals, not in small letters like this. And I'm pretty sure that the contacts inside had corroded to a degree, because sometimes things wouldn't be working right. I'd just wiggle a component and suddenly it'll spring into life, which tells me either it wasn't making contact, or the grasping little header pin, or socket rather, in there had corroded. And I'm happy with these now. I've kept the good ones that I've had. Great, that's the first thing. Now, next, let's talk about Arduino type boards and how we can improve on that. Now, when I say what we're going to do about these boards, I don't mean we're going out and design our own or build our own or anything. It's what alternative boards can we use instead of the ubiquitous Arduino Uno or clone, something like that. I mean, this works all right. It's a bit big, isn't it, for what there is on it? Oh, sorry, should have used my pointer again. It's large, physically large, which might help in some situations where, you know, you're a beginner and you want to get into all these contacts and things. But these are generally quite big for what purpose they serve. Now, you can, of course, get nanos like this one here. So this bit, in case you're not totally familiar with this is a nano. I'm trying to get unplugged. There we are. That's a nano. Now, electronically, this is identical to that. All right, so it's quite a bit smaller, isn't it? and it actually gives you two more analog inputs, A6 and A7, and you can only use those as analog inputs. You can't use them as GPIOs like you can the other analog pins. And it's got a mini USB socket on it rather than the micro. But that's okay because you can use an adapter. He said, looking for it, here we are. So I use this or the fixed one. So I've got the mini socket on that end and a micro on there, because all these USB cables call some micros. That plugs into that, and then that plugs into this nano board. But the nano board either is designed to go onto a breadboard, but that hardly leaves you any room whatsoever to do stuff, or it plugs, as you saw, into one of these, which I can just about do again. And then, of course, you've got lots of pins, because each pin is brought out here with plus 5 volts and ground for each GPIO. So that's very useful. And then you still have all these pins directly, so you can connect two things up or whatever, whichever way you want. Now that's great. That's okay for development, because then when I've used these for development, I then use the actual nano by itself with the pins, the pins themselves soldered the other way up, so I can just plug stuff in from the top for an actual project. That's great. However, sometimes it would be nice to use a Mega, not least because it's got 52 pins ish. It's got, what is it, six serial input outputs, 6 or 4, can't remember now. Mainly because I don't use these. It's just, if we thought the Arduino Uno was big, I mean, look at the size of this. If we just compare, well, this is the same size as that Uno board. So I mean, talking, 1 2/3 perhaps, and that's quite a big board, isn't it? Now, if size isn't an obstacle in your project, you're building something big anyway, I guess it doesn't matter. But for most of us, we're trying to put these things into cases, and the bigger it is, the more difficult it is to connect it up. And I don't like this Uno style socket. This is a full-size socket, and well, nobody uses those anymore. As I say, even the Nano uses the Mini, and this one uses the Micro. All these clones use micros. So whilst this works, let me just plug that in. Here it goes. Yeah, dry, and we should see some, I think, blinking LEDs on this. Because what I normally do when I get new boards is immediately upload a multi-blink program. There it goes, 4 flashes I think I've got on this one. Yeah, just to prove that it's all okay. Well, as far as you can with a blink program anyway, so that's fine. But what if we could get something smaller than this, but still with the power of this? Well, what could we use, I think? Perhaps we could use, he said, one of these. What's one of these, I hear you ask? Well, we look at the outside, it says Mega 2560, yeah, Pro. Hello, what's that? Now, if I told you that this is exactly the same electronically as this Mega, we might think, wow, actually, I mean, how much bigger is this? This is probably 1, 2, 2.25 times the size, the full size, isn't it? But this is a full size Mega. In fact, we can prove that, because if I connect, this has also got a micro, so I mean, so if we connect that up, he said, cack-handedly, there we are. Now this has also got the multi-link, so it should be flashing, I think it's 4 times. There it goes, 1, 2, 3, 4, yep. Awful shame, isn't it, to use a Mega 2560 just to flash a little LED, but that is exactly equivalent to this, but it's actually smaller than an Uno, as you can see, quite a bit smaller, in fact, shorter. And there is, in fact, a version of this that's even smaller than this, but I wouldn't buy it. Personally, I'm not recommending that you don't buy it, because it was missing, what was it missing? It was either the socket or some pins, and I thought, no, I do want all the pins. Now, what's the downside of this then compared to this? Well, the first thing you can see that the pin layout, well, obviously because it's smaller, it can't use the standard shields or anything for the Mega, but the pin layout is very much like the Raspberry Pi, isn't it? Where you've got a double row of pins on each side, because obviously you're trying to cram 52 pins in around the outside. So once again, you'd have to know where those pins are. I think it probably tells you underneath. Yeah, there's let me turn it the right way up. There we are. Look, so it tells you where they are. And I haven't even soldered those header pins in. Look, they're just sort of sat there by friction. So you can see where the pins are, but that's not quite as convenient, is it? Because when you're on this side, if we just get in there with the light, okay, you can just about make out that bottom row, but you don't have no idea what this top row of pins is unless you turn it over and have a quick look. And given that you're probably going to solder this row, so it's going to hide some of that writing, you don't have to refer to this one up here. It's probably why they do it twice. Yeah, but, well, there's always a trade-off, isn't there, between size and usability, I suppose. Anyway, so that's just something I thought you might be interested. We'll have a look where I got that from right now, and then come back to what I used to program this with. So this is where I got it from. This is AliExpress. It is RobotDyn, the makers. I don't know whether this is the actual seller I got it from or not, but they're all over the shop in AliExpress. So £6.75 plus £1.58 shipping. I'm not sure I found it cheaper. I think I'd paid a little bit less actually, but maybe the dollar-pound conversion rate has changed since then. But yeah, okay, it's a little bit more expensive. Well, okay, let's not hide things. It is quite a bit more expensive than, say, a Nano or an Uno. You can get an Uno for what, £2.40? So this is probably 3 times that price, but then you're probably getting 3 times the memory and stuff, aren't you? So let's just have a quick look at that. There's some more pictures of it here. Yeah, well, you've seen that anyway in the video now, haven't you? So yeah, 833. There's probably more places you can get it from, but it's certainly worth a look, I think, because to get a Mega this small, but it is absolutely electrically the same, it's not to be sniffed at, as they say. Well, as I say. So there we are. Fairly good value for money, and quite frankly, given the size factor of these two, I mean, I'd go for this every time. Even if you wanted to develop on this one, because it's just easier to get at and you can read all the pin numbers on it, then when you could put it into production, you could use one of these, couldn't you? So it would shrink this down by quite a bit. So let's have a quick look, very quick look, at what I used to program this, because it wasn't the Arduino IDE. What else could I have used? It wasn't Sublime Text, and it wasn't the Slober IDE Eclipse version either, but it was very close. Let's have a look at that. So here we are on screen with the code window open. Now, as you can see, that's not the standard Arduino code window by any means. This is, yes, Eclipse. And I can hear you all saying, but hang on, you often use Eclipse in your demos, and that is true. But this is not the same version by any means. This is, how can I put it? This is the official Eclipse version with the Arduino add-on. So no nag screen, all free. Slight difference in the way you work though, because if you look down here, can you see the INO suffix on the file? And the rhetorical answer there is no, you can't, because this isn't an Eno of any kind. It's not an Arduino as such, is it? This is just C++ IDE running in Java like the standard one does, but we've added in the Arduino add-on, the official Eclipse Arduino add-on, and of course it knows nothing about Enos, Arduinos or anything else. It just has been well, tailored to call up the correct toolchain set so we can have the GCC compiler and so forth putting the code down onto the boards. Fine. Now, I'm not going to go into how I did all this because I haven't quite mastered it all myself. I've managed to get it working for all the Arduino boards. I managed to get a simple ESP8266 running, so that's fine. It knows about ESP8266. Well, I haven't got it going through the ESP32, but it should be able to support that. Well, as I say, early days yet, but as you can see, I mean, it doesn't look hugely different from the standard Eclipse one because, well, mainly because they're all built from the same platform. It's nice to see when we're loading this up onto this board, though, that it does come up somewhere. It says, I think, there we are, this bit here says, oh, I've read the device number and it's probably a 2560, probably. Well, luckily it was. So yeah, does it somewhere? It says the maximum you can write. No, I've lost it. There we are. I've just clicked that thing at the top there, that hammer for build, as you can see, and it says nothing to be done because I haven't changed the code since I last done it. But 4,385 bytes out of a maximum of 253k bytes, and we've used 328 RAM bytes out of a maximum of 8k. Much bigger than the Arduino, and as I say, because the size is even smaller than the Arduino, the only thing that stops me using this permanently for all my sketches that I currently use a Nano for is the price, because whilst it's not, I would say, expensive, it's all relative, isn't it? And you can probably get, what, 2 or 3 Nanos for the price of this, but then we are getting 2 or 3 times the memory and everything else, aren't we? So food for thought. I'm probably going to look into this board a little bit more, but I'm currently looking into the ESP32 as well. That's not quite mature enough yet, I don't think, for everyday use, although I'm sure thousands of you are currently saying, oh yes it is. And yeah, it is if you're willing to get your hands pretty dirty. But remember, this channel is for beginners, really, I suppose. So for a fairly new Arduinoite trying to follow an ESP32 build, it could be just that wall too much to climb over. But believe me, I'll be looking at it in much more detail as time goes by. In the meantime, of course, I'll show you where I got this from, this download, in the stuff below this video, and it's pretty easy to set up. In fact, there was even a video. It's a little bit old, but it pretty much was okay. This version, incidentally, is Oxygen 2. Does it say that? Let's just have a quick look. Yes, Oxygen 2. Now, the previous version was just called Oxygen, which I tried and frankly rejected because it was just too faffy. But Oxygen 2, they do really seem to have got their act together. So if you want to take a quick look at that, I'll put the link for the video, as I say, and all the source below this video. You might feel brave enough to think, yeah, I'll have a go. And there's no harm in trying. It won't destroy anything else you've got on your PC. In fact, this is currently running from my downloads folder. I didn't even have to install it. I just downloaded the file, extracted it into another folder in my downloads folder, and it all ran. So there we are. And then I just installed the add-on. Now the add-on actually comes into... Yeah, here, look at this. You see, on the help, it says Arduino Downloads Manager. Now, I wouldn't expect that to be under the help. I'd expect that to be, I don't know, in tools or something. So some of the things are a bit odd. Preferences, when that comes up, that also somewhere, oh, there we are, has Arduino stuff. Now this, you might recognise as the extra bits when you go into the standard Arduino IDE for adding in the JSON address for all the different boards. And you can see the ones I've currently got on there. But some of the menu items are in what I would call unexpected places. They're not wrong, they're just unexpected, because it's a different way of working. And as I say, because we are now running in C++ mode, that's it. Your file extensions will change, but it does understand, as you can see here, everything there is to know about Arduinos. So all the language, all the hand holding rather, is still there. Good stuff. Right, and because it's Eclipse, when I hover over stuff like that, look, you can see exactly what it does. Yeah, that's pretty good. So there's the delay. I've done this before in a couple of other videos, which shows you the underlying code. Not that one though. Anyway, that's it. This was supposed to be a short video just to fill in while I'm getting my workshop sorted out, my new workshop. Which, incidentally, if you're watching this and haven't yet read my blog. Yep, that one on screen now, that one, yeah. That's going to detail various things throughout the year, whether it's additions to this channel or just comments, just things I've found out about. Do have a read, do subscribe. You know, trying to get your friends to subscribe as well. Why not? I want to get the numbers up on that blog so we can have a bit more of a community feel to it. Thank you very much indeed, incidentally, for those people who have already subscribed to the blog. And left comments. I promise not to overload you because you'll get an email notification every time I upload a blog, but I'm not going to do it that often. You know, once a week, maybe twice if there's a lot to say. But then, of course, you'll get a video every couple of weeks or so. So let's not overload you with information. Anyway, thanks very much. That brings an end to this video. Hope you enjoyed it. If you've got any questions, do put some comments down below. Yeah, so don't feel restrained in doing that, or backwards in coming forwards, as they say. So do leave a comment, ask any questions, or go to the blog and put a few questions on there. Great. Thank you very much for watching, and I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.